So in this video, we will be discussing about architecture patterns. So let's start. So whenever we are design a system, there are three major types of architectures that we follow. First one is monolithic architecture. Then we have service-oriented architecture, also known as SOA. Then we have the third one known as microservices. So we will discuss about each of these architecture patterns in detail. So let's first discuss about monolithic style. So a monolithic application is built as a single unit, one big application in a single language that handles all of the functionality, data, business logic, etc. And a load balancer distributes requests from the end user across multiple machines, each running one instance of our application. And all logic for handling a request runs in a single process. That allows you to utilize the primary features of the language to divide up the application into classes, functions, and namespaces. So monolithic style was a very popular style in old times because it's very easy to develop applications in monolithic style. So monolithic style has several advantages. Because of that, it was very popular. So the first advantage is that the initial development is very fast. With one application, it would be relatively easy to add additional features, especially when the application is relatively small. As this is contains a single application, so developers need not have to learn about different applications. So they would focus into one application only. Because it's a single application, this improves integration among different functionalities. So these are some of the advantages that monolithic architecture has because of it was very popular in old days. Now, what are the disadvantages? So the one major disadvantage of single point of failure is single point of failure. So if any application function or component fails, then the entire application goes down. Suppose in a web application with separate functions handling tasks like payment, login, etc. So a function begins to consume more memory or CPU. In this case, the entire application will come to a halt. The second major disadvantage of monolithic application is horizontal scaling. So scaling applications can only be accomplished by deploying the same WAR or EAR packages in more servers. So every single copy of the application in different servers will use the same number of primary resources. Because of that, it's not an effective way to design. So other disadvantages of monolithic pattern was whenever the application grows, the code base also grows with it, which can overload the IDE every time it loads. Because of that, it reduces developer productivity. And a small change made to any part of the application, it requires the entire monolithic application to build and deploy, which is also a very time cumbersome process. Because of that, maintenance cost will also shoot up exponentially with the size of the application increases. Monolithic applications have high setup costs. So in order to get each new volunteer up and running, the larger application, the more difficult it would be. So let's now talk about service-oriented architecture. Service-oriented architecture defines four basic service types. So first one is business services. Then we have enterprise services, application services, infrastructure services. So these are four types of services that are used in service-oriented architecture. So what is this functional services? So Functional services or business services are nothing but coarse-grained services that define core business operations. They are represented through XML's business process execution language, also known as BPEL. And then enterprise services, they implement the functionality defined by the business services, and they mainly rely on application services and infrastructure services to fulfill business requests. Then we have application services. So in case of application services, fine-grained services that are confined to a specific application context only. And in application services, we have a dedicated user interface that can directly invoke the service. Then finally, we have this infrastructure service. To implement a non-functional task such as authentication, auditing, security, and logging, we use infrastructure services, and they can also be invoked from either application services or enterprise services. Now, let's have some example of service-oriented architecture. So as you can see, a bookstore application has been implemented using service-oriented architecture. And four crucial distinct segments of such an app are account service, books, order, and shipping. The service-oriented architecture says that each segment should have its own services. This is why four services are built in provider's layer. So all of these are connected to a pool of databases that store all application-related data. This is where coupling comes in. Services cannot be tested or modified independently because they share their data stores. An interface, also known as ESB, Enterprise Service Bus, in this case, unifies all services together and exposes API for the front-end clients to communicate with the provider layer. So basically, the consumer's layer can have any kind of application that can interact with the SOA interface. And you can reuse the same provider's layer for a variety of front-end clients and endpoints. So this is all about service-oriented architecture. So let's now discuss about microservices architecture. So in microservices architecture, applications are built as suites of services, which is also a modular approach. Each microservices exposes a common API, which are accessed through the network. And API calls are stitched mostly on the server to produce a page. Although few of this work is executed by the client querying individual microservices. So big enterprises, players such as Amazon, Netflix, Uber, Yelp, and eBay, they have adopted microservices because these services are independently deployable, scalable. Each service offers a secure module boundary that allows different services to be written in different programming languages. Now, what are the advantages of microservices architecture? So first advantage is improved fault tolerance, improved fault isolation. So larger applications can remain largely unaffected by the failure of a single module with microservices. So it also removes the dependency and eliminates long-term commitment to any single technology stack. With a split of functionality, it gives more room for new developers to understand the functionality of a service and make enhancement easily. Easy deployments, microservices-based applications are deployed inside containers that provide better management. So these are all the advantages behind microservices architecture. Now, what are the disadvantages of these microservices? The first major disadvantage is that in a microservices, there are n number of services which perform a particular task. So because there are several services, it increases the complexity. And deploying microservices can be a little complex. It requires coordination among the different services, which may not be as straightforward as deploying a monolithic application. So, as we already discussed that microservices use multiple databases. So managing multiple databases and transaction management could be very painful task in microservices architecture. Testing could also be cumbersome because each dependent service needs to be confirmed before one can start testing. And handling requests across multiple independent services requires proper workflow management. There can be a scenario where one of the services may not be responding or remote calls experiencing latency. Despite of all the disadvantages that microservices architecture have, the benefit of adopting microservices are a lot more. Because of that, many enterprise leaders such as Amazon, eBay, and Uber, Netflix, etc., they are leaders towards this microservices architecture journey. Now, let's discuss about the differences between SOA and microservices architecture. So, SOA follows a share as much as possible architecture approach, whereas microservices follows share as little as possible architecture approach. In SOA, importance is on business functionality reuse, whereas in microservices, importance is on concept of bounded context. SOA has a common governance and standard, whereas microservices focus on people, collaboration, and freedom of other options. SOA uses enterprise service bus for communication, whereas microservices use simple messaging systems like MQ and or Kafka. SOA supports multiple message protocols, whereas microservices use lightweight protocols such as HTTP REST. SOA is multi-threaded with more overheads to handle IO, whereas microservices is single-threaded that usually with the use of event loop features for non-locking IO handling. SOA maximize application service reusability, whereas microservices focuses on decoupling. SOA traditional relational databases are more often used, wherein in microservices, modern relational databases are often used. In SOA, a systematic change requires modifying the monolithic, whereas in microservices, a systematic change is to create a new service. In service-oriented architecture, DevOps continuous delivery is becoming popular, but it is not yet mainstream. Whereas in microservices, strong focus is on DevOps or continuous delivery. So I think this is all we had in this video. So in this video, we discussed about monolithic application and this service-oriented architecture and microservice architecture. I hope after watching this video, you have some better understanding of these architecture patterns. Thanks for watching this video, guys. Thank you.